What I want to do, as soon as I figure out forward and reverse here, is to talk to you about something that is an emerging trend in a lot of different places. What do we mean by these alternate on-site sources of water? Well, one thing from the dollar side, it's pumps and it's pipes and it's tanks and it's things that we can design and install and make money on. That's something that's good for people that are in the engineering and plumbing business, believe me. The other part of it is, though, first is that it involves a lot of different things. Here's just a partial list of alternate on-site sources of water that you can catch and use and reuse, and I use those two specifically on-site for different types of things. You start out here with the classic everybody thinks of, and by the way, you use rainwater. You reuse graywater. Rainwater, and Bob, where are you at here? There he is, the president of the American Rainwater Catchment Systems Association, Bob. And he's going to talk about rainwater in a little bit, and I will not talk a lot about it because of that, because he's a lot better expert. But just look at all the lists down here. And by the way, just last week after I'd sent my topic in, I came across a very interesting one. I came across it was at a show, and the guy had a big panel up there behind his display, and it says, "Water your yard with your furnace." And I said, what? He actually had a condensing unit that would, we all design our heating units so that we don't ever hit the dew point of the exhaust head, the gas from there. Well, he actually was condensing with stainless steel, I'd tell you, and was actually capturing this water, but he was also getting 95% instead of 80 or 85% out of his boilers or large commercial hot water systems. And what was interesting is he said he had one place up not too far from where we stand where he was collecting 400 gallons of water a day out of that system. Has a low pH, but that's great for cooling tower makeup. And for most soils, it would have been just fine because the low pH was because of the carbon dioxide. So, going on with that, there are a lot of different things we get into here. What is pushing all this? First place is the cost of water and wastewater treatment. Capital cost, infrastructure costs are going through the roof. Finding a new water supply is going through the roof. It was mentioned in California, they're doing desal. It was mentioned in Australia, they're doing desal. Texas has almost 100 million gallons a day of desalination capacity, and a lot of it's inland. The largest desalination plant in the United States is a 26 million gallon a day plant in El Paso, Texas. Look at your map, 500 miles from the coast. They're taking brackish groundwater and desalting it for $1.50 a thousand gallons. Now that's difference. Going green, we've talked enough about this, the limited supplies. Stormwater and other factors. Beautifully brought out this morning by head of the EPA. Admiral hit it right on the head. We have a very symbiotic potential here to work with both our stormwater people and our rainwater harvesting people and our water people on developing that stormwater, which is really rainwater. It's gotten dirty because it hit the pavement and run off, and we can do a lot of things with that, as you'll see. And again, just overall environmental considerations. A lot of reasons for doing it. Again, I mentioned a few of these here. I'm just let you look at them. I'm not going to read them, but besides, I will mention one thing, that besides the on-site sources, there will be a purple pipe in your city, if it's not there now, soon. And that is bringing reclaimed water from the municipal system. I'm going to talk about those sites that you can actually collect on site, but that's another very important component to consider. And some of the other costs here, again, you can look at them. These are just good reasons to get into and take a look at that. Besides the point that you're saving water and you're making a lot of work for people like us who are in this business. Now, I do mention here stormwater regulations. You can collect rainwater and stormwater before it gets into the wastewater system. Now, whether that's a separate stormwater system or a combined sewer, you're saving a whole lot of money on the getting rid of water side too. Just, guys, there are more symbiotic things around here than you can, as they also say, shake a stick at. I use words like that because I'm from Texas, and just so you know, the plural of y'all is all y'all. But anyway, a lot of different things, reasons for catching that water on site. And we get to the fact that the cheapest water you'll ever have is the water that we already have. Let's make use of that. Now I will get off my soapbox and into some specifics on this as we go through here. First place, what are the opportunities? Well, you know, if you're looking at a site and you're saying, gee, I want to make use of this, you know, that person wants to get lead credit. And by the way, Bill, wherever you were, the question that you asked EPA director was, when are we going to get lead up on water was so beautifully addressed this morning. We'll talk more about that. It's been a long, slow process. Match the source to its use, cost consideration, regulations, and incentives. I use those both in the same line there. That's kind of a weird way of doing it. And some examples. Well, first place, where can it be used? Almost any place you can imagine where the water, volume, and the quality, either before or after additional treatment, fit the use that you're looking at. And that is the first and important consideration of it. I see some extremely interesting things that are happening all over the United States. Wetlands recharge, catching stormwater and putting it in a wetlands recharge. So then it becomes, later on, groundwater and aquifer flow. It's water to keep baseline flows and streams. That's something we wouldn't normally think about, and we probably wouldn't get directly involved with, but there are just so many different areas where you can use this stuff, which gets to matching the source to the use and the quality, the treatment, and the quantity of the source. In a home, we have what we call black water and gray water. Gray water is water that you collect from the shower, from hand washing laboratories, and from the clothes washers. It is not water you get from the toilet or from the kitchen sink or the dishwasher. That is the way it's defined by IAPMO at this time. We're not limited to that because we also have black water that is produced. It obviously can be treated and reused. And we'll talk about some of the way that some of the states are approaching this. This is a residential size type thing. We're looking here again, the amount of water used. The old homes, you could use as much as 100 gallons per person per day, way back in the 70s when nobody cared. Under our current best practices, we're using 35, 40 gallons is as best you can do. That's with the most efficient clothes washers, the most efficient dishwashers, toilets and showers and on down like that. But if you can get that down to 30 or below if you catch that water, treat it, and use it for toilet flushing. Some of the things we got into. Now, I could go on, but let me look at some other things. By the way, there are all kind of gray water residential systems, everything from reusing all your gray water. The current IAPMO or Uniform Plumbing Code is only for subsurface drip irrigation. This would allow you to use it for plumbing and for some other types of uses for spray irrigation outside the yard, all the way to some pretty direct gray water reuse. It's a little system kind of cute that takes water from the hand washing laboratory and uses it for toilet flushing after some filtration and some pumps and some treatment.